Around the world, there are factories making everything from biscuits to bikes. With mega machines mass producing and highly skilled workers handcrafting, they are the products we use every day. But have you ever wondered how to make a vacuum cleaner with personality? How to cast a porcelain throne that is fit for a king? Or bake Scottish shortbread on a massive scale? Well, sit back as we go behind the scenes on the production line. Vacuum cleaners, perhaps the ultimate labour-saving device. They've been around for over 100 years, but none are held in quite as high regard as Henry. This friendly face is nearly 40 years old, and an army of 10 million Henrys can be found in homes, hotels and offices all around the world.
There's very little that you can do to upset a Henry. You can use him very robustly. You can use him all over in lots of different applications and he'll still come out smiling.
Henry and his multicoloured family are made by a team of expert technicians led by Stuart Cochrane.
I've worked here for 10 years and I was amazed when I joined that all the main components that we use for the Henry are made in the factory here.
Most of Henry's 85 components are made on-site from injection moulded plastic, which requires a plentiful supply of raw materials.
Well, we're here at the back of the factory, which is right at the start of the process of us making the plastic components that go into the main bits of the Henry machine. So the big silos, and we've got 9 silos around us, hold up to 30 tons of material. And all of the material is in pellet form, and it's then transported into the factory in vacuum pipes and are distributed to all the machines where we're making all of the different components from the Henry. And we use about 5,000 tons of material in the factory every year.
The majority is a plastic called polypropylene. It's a tough, versatile material that's used to create Henry's red body and accessories. The pellets are stored in bulk silos until they're called for at various points around the factory.
The material has come from the big silos outside, and it looks like this, these pellets, and it comes through the pipe to the manifold where it is then distributed to the rest of the machines through the different pipes right round the factory.
The white plastic pellets can be coloured to produce parts in any of the 6 colours used across the range.
When the pellets come into the factory, we mix them with a master batch to give them the particular colour that we need for the products, and then they get transferred into our injection moulding machines to make the product like the drum that's being made behind me.
The pellets are sent to 39 injection moulding machines around the factory, where they're heated and squeezed into precision-engineered steel moulds. The moulds are held together using up to 600 tons of pressure to ensure the molten plastic sets in exactly the right shape. The injection moulders run 24 hours a day and can make up to 1 million different mouldings each week. Once cooled, robotic arms remove the components and drop them onto a network of conveyor belts ready for assembly.
This is the very start of the assembly process, where we have 7 production lines. We have about 80 staff here working on a double shift system, and they make about 4,500 Henrys a day, which equates to about 20,000 a week or 1 million a year.
The black head of Henry is the most complicated part. It contains the motor and electrical switches, all made by an in-house team of crimpers and splicers. The first part to be assembled is the cable reel.
We're bringing together some of the mouldings that we've produced from our injection moulding machines and making the reeler top that goes into the top of the Henry and winds the cable on to the Henry, which a lot of people know Henry for. And you buy the product with it wound in, so we have to wind the cable in here.
The 10-metre long cable gives Henry extra reach over his shorter range rivals.
So this is the main bit of the Henry head. It's the sort of internal workings of the Henry head. So we've got some contact rings at the top so that we can put the reeler and the cable on top. and some electrical connections at the bottom so that we can do the motor, and the switches and the light that shows that the machine is connected to the mains. We put a switch cover over that to protect the contacts, and then we finish up by putting the Henry cover onto that so we can transport it all together and ship it to the line effectively.
The 620-watt motor needs to be powerful enough to suck up the estimated 1.5 million skin cells we shed every hour, many of which end up in our carpets, which researchers say contain up to 4,000 times more bacteria than a toilet seat. But of course, Henry's staying positive, as next door, a robot is sponge painting that famous smile.
I think the smiley face is great because everybody recognises the product and knows that it's a Henry. And then if you're using it in a commercial situation, maybe you're on your own while you're cleaning and it becomes a friend who's working alongside you rather than just a machine that you're using.
First imagined by company founder and owner Chris Duncan, Henry's smiling face was originally meant to cheer up office cleaners working on social hours. But his reliability and efficiency, not to mention his positive attitude, soon made him a hit in the home too. Over the years, the Henry family has grown to include over a dozen variations, offering up souped-up motors, bigger capacities, and even a wet vac function. Back on the production line, Henry's classic red drum is taking shape.
So this is where we assemble the drum ready to go into the final assembly hall. So we put on the casters, the wheels, and then we put in the 2 layers of filtration, which is the bag and the Tritex filter. The filtration process is good because the filter helps the bag to work more efficiently, and also there's 3 layers of material in the bag that allows the air to keep moving through while trapping all the dirt. Oh, the smile gets put on at the same time.
The 6-litre capacity lets Henry pick up more dirt and debris than any house-proud owner would care to admit. A flexible hose will connect the drum to an aluminium handle, known as the wand, which is also made in-house.
So we start off with a blank piece of metal, and we put a hole in it and we have to bend it like this one, and the hole in it is for the volume control, and it all makes sense when we make the straight piece as well to put it together and everybody would recognise the Henry vacuum cleaner.
But our Henry isn't a one-trick pony.
So here we have what we call our 5-piece kit. So it's the kit of tools that goes into the Henry to help do lots of different jobs with your Henry. We used to have it manufactured in the Far East, but we decided to manufacture it in-house so that we had control over the production. What we call the crevice tool, which is really good for getting into little spaces, like in the arms of your armchair or down the seats of your car. An upholstery brush that you can do things like mattresses with it without the brush, and then again things like sofas when you attach the brush to the holder. A dusting brush with horsehair in there that's really good for dusting. So I use the soft dusting brush with the volume control of the wand open to dust things like Lego models so that you can take the dust off without sucking up all the bits.
And all these years, I've been dusting my Lego by hand. The final assembly hall is where the head, the drum, the wand and accessories come together.
This is the bit where right across the business we've been making lots of small components that you might not recognise as being part of a Henry. They all come together on these production lines and are put together by the team here. We have an automatic screwdriver that does the 7 screws up that holds the Henry head together, and a robot to pick the head up and put it onto Henry's drum. We built this entire production line ourselves, and it not only improves the quality of making Henry, but also reduces the work content for the operators, so it makes it less stressful for the operators to work on the line. I think there's always a happy smiling face going down our line, so I think that always looks good.
Once the head is attached to the drum, each unit is thoroughly tested to make sure it's working properly.
We've designed an automatic test station where every one of our products goes through a performance and an electrical test. We also take a photograph of the Henry to check that it's got the right face, it's the right colour, it's got the right printing on it, and that it's performing as we expect it to perform.
And every one is built to last.
it's very robust. There are a lot of old Henrys that go beyond their life cycle that we can repair in-house and give people spare parts for it.
And that toughness is down to a brutal testing regime. Next door, a team of Henrys are being poked, prodded, and generally mistreated for thousands of hours.
We put it through an enormous amount of testing and development to make sure that the machine is robust and capable of standing up to anything that any user can throw at it. So these brushes have swept almost 200,000 times already.
And the poor little things are still smiling. Back on the production line, the completed vacuums are nearly ready for dispatch.
So this is the end of the production line, and we're making 2 machines every minute. And the production line picks up the Henry and puts it into his box. And then we pack all the kits and accessories that go with the Henry into the box. So off the top of my head, we make 2 machines a minute off the line, which is 120 an hour. So over our 2 shifts, it's almost 2,000 a day off this line alone. I'm really proud that Henry's made in the UK. It's really nice to run a factory that provides jobs for people and produce an iconic product that lots of people recognise around the world.
And don't forget all those winning smiles. Whether you prefer a raspberry ripple or chocolate chip, ice cream is a sweet treat enjoyed by millions of people every day. The global ice cream market is worth nearly £50 billion. And Mackey's ice cream makes some of the best out there.
We've been here now for over 100 years. There's been 5 generations of Mackey's.
Originally a dairy farm, Kirsten's dad founded the ice cream factory 30 years ago.
I grew up here on the farm. I was born here. I spent quite a few summers actually milking the cows, getting up at 3 a.m. and so all really, really good fun. I mean, it couldn't be a better place for a kid to grow up than this.
This family business now makes 10 million litres of ice cream a year. That's a whopping 100 million scoops. Talk about brain freeze.
We started making ice cream because more and more people were buying semi-skimmed and skim milk, and there was a huge amount of cream. And we thought, why not? Let's make a good quality ice cream. And from there, it's just gone from strength to strength.
The farm buildings now house a state-of-the-art ice cream dairy and packaging plant. They churn out 10 different flavours, from Madagascar vanilla to mango and passion fruit. But the most important ingredient in each of them is fresh milk.
It's a very special milk for us. It's not many farmers that would be able to produce the type of milk we have for our ice cream.
The milk comes from 3 different breeds of cattle. It's this combination that's claimed to make Mackey's ice cream extra creamy.
We've got Friesians, and we've got some Jerseys, and we've got a special breed called Swedish Reds.
And rather than being herded into a barn and milked twice a day, these clever cows choose their own schedule.
We've got a really special way of milking. We've got an automated process, which we love, but more importantly, the cows absolutely love it.
This high-tech robot milks the cows at their convenience. It's claimed to be less stressful for the cow, which means they'll produce more milk, of a higher quality, which means even better ice cream.
It allows the cow to milk 24 hours a day, as many times as she wants within the parameters that we've set, and they just have the freedom to go in whenever they want. It allows the udder, which is the working part of the cow, not to be swollen at any one time with milk, and it just keeps one of the stresses off the cow.
A spinning brush first gives her undercarriage a good scrub. Then a bank of lasers pinpoints each teat before a milking cup is attached. The robot tracks the quality and quantity of each cow's milk, so the team can spot any health issues early on.
I'd no longer have to milk in a parlour 2 or 3 times a day. We don't have to push cows around into a parlour, which sometimes they don't want to go. And basically the cows milk themselves, and we just actually look after the robot and look after the cow's husbandry.
The herd produces up to 8,500 litres of milk a day, which is tanked up, ready for use in the dairy just next door.
So we're now in the ice cream dairy, and this room is the processing room. So this is where we actually make the ice cream mix. And we've seen the cows being milked. The milk's stored in a big tank outside, and we take in the exact amount of milk that we need for each batch, comes up through this pipe, down and then into the main mixing unit over here.
The ice cream is a mixture of fresh milk from the dairy, cream, skimmed milk powder and sugar. The cream and skimmed milk ensure a smooth, velvety texture, as well as a long shelf life.
So the next part of the process is we're heating the milk and the cream to a really, really special set temperature for maki, and that's really critical to the maki taste. And once we get to this secret level, the sugar is added, which creates a perfect environment for the skim milk powders to be added. And that creates a bit of a chemical reaction.
Scientists call it the Maillard reaction. It happens as heat transforms protein and sugars to produce mouth-watering tastes and smells that are almost irresistible. And to get it right, timing is critical.
It's really, really busy, and it's so quick as we have all the various different ingredients that have to be added at specific temperatures very, very quickly. And each batch is done within 20 minutes, so it's really bang, 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 get it done, and each time done exactly the same, so we've got a consistent product day in, day out.
To keep up with production, staff must constantly ship in the ingredients. That's some bag of sugar. Each 2,500 litre mix uses 300 kilograms of sugar and 120 kilograms of milk powder. That, when frozen, will make between 4,000 to 5,000 litres of ice cream.
They come along this white pipe here, and they're weighed and they're held up in a vessel. And at the exact second, right second, when the temperature's right, the weighed product falls into the vat and then vigorously mixed in with the heated milk and cream. It actually, it can fly off. But it can be quite dramatic when the skim milk powder comes into the air and coming down into the vat. So we've got two different mixing vessels. Each one holds 2,500 litres, and they take about 20-25 minutes each. And we're continually running one up against the other all day. We sometimes do about 20 batches in a day. So now we've got the milk, the cream, the sugar and the skim milk powder all completely mixed at a very, very special temperature. We then add some sugar syrup. And the reason we add some sugar syrup is to just get a very good scoopability to the ice cream. We're in this tank for about 20 minutes, and then when we're absolutely certain it's all completely mixed up, we then pass it through to this machine over here, and this is the pasteurizer. It's then very, very quickly passed through here within 30 seconds.
The pasteurizer heats the mixture, removing bacteria to extend the ice cream's shelf life, before it's fed into the homogenizer.
And what the homogenizer is doing is it's breaking up all the fat globules to tiny little tiny globules and encapsulating them in the proteins, and that's giving a really, really creamy taste to Mackie's ice cream.
The mixture is forced through a small opening at high pressure, forcing the fat globules to break up, creating a thicker, creamier texture. The mix is then chilled to 5 degrees C before it's pumped into the aging room.
So this is the aging room, and this is where we let the mix sit, chilled, and it slowly agitates, and we leave it here for about a day. And when it's passed into these tanks, this is where we might add a flavouring. So we do have a product called Mackie's Indulgent Vanilla, and it's a Madagascan vanilla, and it's the real McCoy. It's a vanilla essence made and brought in from Madagascar. Our second bestseller is honeycomb, and all that is, it's just Mackey's traditional ice cream with bits of honeycomb dispersed through it. And the honeycomb itself, we make that here on the farm as well. My favourite is the chocolate ice cream, and we also actually make chocolate, and we use our own real chocolate to make Mackey's chocolate ice cream.
2 scoops, please. But before it's ready to be tasted, the mixture needs freezing.
This is where we take the ice cream mix from the aging tank, which is through the other side of that wall, and it comes along this pipe here, and it goes into one of the ice cream freezers. We've got 6 ice cream freezers. The mix goes in, and each of these machines can process 1,100 litres of ice cream in an hour. The mix is going in at sort of about +5 degrees, and it's coming out roughly about -5 degrees. And it's incorporating a little bit of air so that you can scoop the ice cream. As you can see, all the pipes are all frosted over. So it's then passed through these pipes, goes all the way along here, and it goes right along there to where it's deposited into the tubs and lidded. Well, this part of the process is really exciting, because this is the part where the ice cream is actually deposited into the tub. And as you see, it's all quite exciting, this bit. There's lots of people. It's a bit like a ballet, and everything has to come together right at the exact time so that the ice cream can get into the pot, and then it's lidded, and then it's passed through for further cooling.
This ballet and rubber boots can make up to 75,000 tubs a day, using packaging made in-house.
Our packaging, the tubs and the lids, we actually make them ourselves here on the farm. And we buy in the labels, and we've got this moulding machine, and the labels get passed onto the mould itself. And this is great for us because it makes much more flexibility, and it means that we can actually launch new flavours and do limited editions, and we can do much smaller runs.
The tubs then complete their factory journey by being sent to bulk packaging, where they're packed and stacked onto pallets. Over 850 of them at a time.
So this is a cold store. It's really cold in here. It's like -27. We'll keep the ice cream in here for a minimum of 3 days just to get it right down to temperature before the ice cream can then be dispatched to go to all of the different supermarkets. So we have about 500,000 tubs in here. Quite enough ice cream to keep us going for a wee while. It is really cold. You really don't want to be spending much time in here. Can you imagine? It's -27. In fact, I really need to get out of here.
The ice cream is then ready to be shipped to ice cream parlours and supermarkets around the world. It's all a far cry from the farm's humble beginnings.
I think Mum and Dad would be really, really pleased to see the business growing with the family and the next generation coming on and doing the same.
You know what, Kirsten? I think so too. Armitage Shanks. It's a name people are often relieved to see facing them.
If you think about everything that you might see in a bathroom or a washroom, we are likely to manufacture it.
Their factory have been producing porcelain products for over 150 years.
The site we're stood in today was the first full sanitary ware production site that was built, and that was back in 1851. We were the first business to connect water closets to sewerage systems, which is obviously a huge contributor to public health. And I suppose on the lighter side, we were the first business to come out with the famous avocado sweets, and that was around 1969. And there's still some, I think, installed today.
One of their best sellers is, of course, the loo.
We manufacture over 1,000 toilets a day, and from this Armitage site, we manufacture around 1.4 million pieces a year.
On average, we spend around an hour and a half on the loo each week. Over the course of a lifetime, that's over 90 days. So it's important each one works as it should and looks the part. And the man for the job is Ashley Spink. He knows exactly what goes into toilets, so to speak.
This is the first part of the process. It's the delivery bays. We receive up to 75 tonnes of clay and sand a day. The clay comes from near St Austell in Cornwall as raw clay. It's then processed and refined, and then it's delivered to us as a dry material.
All porcelain products, including those in our bathrooms, start out as clay. China clay is a rare type of decomposed granite, which, as you might have guessed, was first used in China. Its superfine, talc-like texture is ideal for making porcelain pottery. Cornish mines like this one have produced over 120 million tonnes of material since it was discovered here 250 years ago.
As you can see, it's quite chalky and dry, powdery. It gets delivered, we drop it through the grids. We then have blowers that blow it into silos. It's held in the silos, ready for mixing. So the next place will be the slip house, where we do all the mixing.
The dry clay is transported into the slip house, where it's mixed with water and sand to become slip.
We've got all this lovely network of piping, and the clay makes its way to these silos over there. They're known as blungers. It's where we do all the mixing. So we add 3,600 litres of water, we add sand to the clay, and it's all mixed up, and the final product is known as slip.
Rather than a solid lump, it's this watery mixture that will eventually be turned into porcelain.
The slip has been mixed in the blungers over there. Once it's been mixed, we pipe it into the sieves. Now, the reason we sieve it is because we need to get rid of any impurities, any lumps and bumps, any contamination. It's like a thick liquid, quite thick in texture, almost muddy-like. This is a very traditional method. We've been sieving the slip like this probably for centuries.
But it's not ready for moulding just yet. First, it needs some time to age.
We've got about a dozen of these tanks down here, and these are storage tanks, and we hold the slip in those for 4 days. This is known as the aging process, and the reason we age the slip is because it's been mixed, it's been sieved, it's been transported. A lot of energy's gone into it. We just need it to settle down now. So it stays in these tanks, these storage tanks, for around about 4 days. We then pump it through this pipe network up into the factory.
The aged slip is pumped into 15 automated casting machines dotted around the factory. Each one produces a different shape and style of porcelain product, including toilets.
We're now at the casting machine. We've seen the slip in the holding tanks, aging for 4 days. It's now been pumped into the machine and into the moulds.
The machines inject the slip material into reusable moulds. Each casting requires 20 litres of the creamy slip material.
The cast machine has a 30-minute cycle, and there's 8 moulds in work on this particular machine, so we'll get roughly 8 closets every 30 minutes.
Made of a microporous resin rather than traditional plaster, the moulds can be used over and over again.
It's a 3-stage process. The first stage is the filling of the moulds, and then the second stage is casting up under high pressure, where layers of slip will build up. And then the third stage is the air consolidation, where the air goes in and hardens the piece, so it's nice and firm to come out, and it'll stand up.
Compressed air pushes the layers of slip together whilst driving out some of the liquid, hardening the cast in the process. Then a robotic arm carefully lifts the cast onto a rail system so it can be moved around the factory.
We use the robot because it's very heavy, too heavy for a man to lift.
The brand new toilets, each on their own tray, then begin their slow journey through production.
So here we are on the factory floor. This is where it all happens. We've made the slip, and now we've pumped the slip into the machines. The machines cast the slip to make the product. The product is then finished off by casters, as we can see working there.
The casters give the toilets a once-over, rubbing them down and cleaning off any excess clay. They may look sturdy, but to be strong enough to be sat on, the freshly moulded clay needs to be dry.
We now have 2 drying processes. The first process is a natural drying process on the conveyors, 4 to 6 hours in the natural air. and then it goes into a drying tunnel, which is about 90-degree heat. It's in there for about 10 hours, where it's completely dried, all the moisture's out of the piece. If we were to put the freshly cast piece straight into the heated dryer, we could end up with cracking. It doesn't like it. It needs to dry naturally. During the drying process, they'll lose about 2.5% of their original size, and this is due to the moisture loss. It's just a natural process with the moisture coming out of the piece. These pots were wet when they went in. As you saw, they were grey. They're now nice and white, moisture-free, chalky and dry. They spent about 8 to 10 hours in these dryers, and now they're ready to be clay inspected.
The castings are left to cool down before they can be handled.
This toilet's travelled on the conveyor. It's made its way to what we call clay inspection. We've got operators who it's their job to tidy the pot up. There's a seam to remove, there's sharp edges, there's bits and blemishes. We've got a seam running through the middle of the pot there, and that's basically where the moulds meet. In terms of quality, their job's very important. This pot must be in tip-top condition.
Those that don't make the grade are sent for recycling, where the dress code is casual. Those that do make the cut are sent on for glazing.
We're on the robot glaze line. So in a shift, this robot line will spray around about 350 toilets a shift. This toilet here has just had 4 coats of glaze. The reason we glaze for 4 coats is to get the right thickness to the glaze, and the glaze acts as a waterproof membrane for hygiene and also gives us a nice white shiny finish. You can do any colour you want as long as it's white.
The paint-like glaze contains a mixture of compounds, including aluminium oxide and melted silica sand. When the glaze is heated, it fuses to the clay cast, giving it a tough, waterproof coating.
So we're now at the kiln area. It's taken the toilet 32 hours to reach this stage. It's going to go into an 83-metre long tunnel kiln. It's going to travel at around about 8 centimetres a minute. It's going to reach a temperature of 1200 degrees. It's in the kiln for around about 16 to 18 hours. So we could envisage the kilns as one big oven. While it's in there under the heat at 1200 degrees, there's a chemical reaction that fuses the glaze to the body, which means it doesn't absorb moisture, which means it's then hygienic. So when the toilet enters the kiln, it's dry and porous, and when it comes out the other end, it's vitreous, it won't absorb moisture, it's nice and white and shiny, and ready for flushing.
Once the glaze has been baked on, each toilet is inspected and tested. Ladies and gentlemen, look away now.
This is the final part of the process. It's the quality inspection. These guys here, they're inspecting the fired ware. They're making sure that it's fit for the customer. And they'll also carry out a leak and air test. So on the toilet, they're looking that it's a good piece, it's nice and shiny, the glaze finish is good, there's no bits, there's no blemishes, there's no cracks. It's got to be A1 for the customer.
In another part of the factory, toilet cisterns are being made using exactly the same methods. As they head towards the packaging department, the cisterns and toilet bowls are made ready to be united in a marriage made in the bathroom.
Every toilet needs a cistern. We call these tanks here. So this is a Sandringham tank, and this is going to go with our toilet. We also had a fitting ready for the plumber. That goes in there, and that's ready to go with our toilet. It travels on the conveyor, it gets palletised to go to the customer in bulk. And then when it's on site, for example, at a housing estate, a new house build, and we'll have a pallet full of tanks, a pallet full of toilets, and they'll meet up at the housing estate.
All ready to take care of business. Shortbread, a sweet, buttery delicacy synonymous with Scotland. It's been made by the Walker family for 120 years from their factory here on the banks of the River Spey.
There's no question Aberlour and Speyside is the best place in the world to make the finest shortbread in the world.
Jim Walker is the 3rd generation of his family to bake their famous biscuits.
Our company was founded by my grandfather in 1898. He worked very hard and he had a passion to make the best shortbread in the world. Essentially, I feel very lucky and very honoured to be part of a company that has had some success over the years.
Don't let Jim's modesty fool you. This family firm is a big success. Every year they make 40,000 tonnes of shortbread that are exported to 120 countries around the world, making them Scotland's largest food exporter.
We employed about 16 people when we started, and now, thankfully, we employ near 1,600. It's made with very simple ingredients, but it's the way we put it all together, using the very finest raw materials, all of which are specially produced for us. It's not just about the recipe, it's the way we put it all together.
It's up to Jim's son Nicky to make sure it comes off without a hitch.
What we are in essence is a big local bakery. So we retain many of the traditions that we used 100 years ago.
The secret traditional recipe calls for flour, butter, sugar and a smidge of salt. Just like biscuit baking at home, the first stage is to measure and mix the ingredients. The first of which is flour.
Well, our flour gets delivered from the southern belt of Scotland. It gets taken up to us in tankers. It gets emptied into our flour silos. We're getting roughly between 600 and 800 tankers delivered on a yearly basis. It's coming in 25-ton batches, and it gets through a sifting system that's outside and then brought into the factory through these pipes, so you can see entering the factory and into our weigh heads for loading the mixers.
The mixers combine the flour with the butter, 7,000 tonnes of it a year. It's the butter that puts the short into shortbread. In baking terms, short means crumbly, as in short crust pastry.
Here you see the butter, and the butter is added to our mixers along with some sugar. And then the flour that we talked about previously gets dropped from the weigh head, and the whole mixing process then begins to get the requisite batch. So we say roughly our batches are 250 kilos.
That's enough to make 15,000 shortbreads, not biscuits, mind you. You see, legend has it that Scottish bakers defended shortbread being labelled a biscuit to avoid paying tax. The tax-efficient recipe requires 3 parts flour, 2 parts butter and 1 part sugar.
This is like in your own kitchen where you cream up the butter and sugar and salt to make the cream to start with.
Whereas some recipes swap butter for vegetable oil to keep the cost down, Walker's only use butter, made from the milk of 30,000 cows. It's a recipe that hasn't changed in 5 generations.
This is the mix now mixed to the requisite consistency. Stuart is now taking the dough out of the mixer to be taken across to the production line.
Once the dough is mixed, it's ready to be rolled and cut into shape.
The next part of the process following the mixing is presenting the dough to the rotary moulder machine. So this is what we call a dough feeder. And its sole purpose is to present the dough to the rotary moulder so it doesn't bridge. If we were to tip all the dough in one big bundle together, it would bridge and it wouldn't form properly. And like when you take dough from home, you've got the consistency right, then you have to make into the right thickness. And this is what these 2 machines are doing together.
The rollers squeeze the dough to form a sheet around 15 millimetres thick.
It's really the bit you would do back at home in your kitchen with any fancy shape you wanted to cut out. But we've done it in a more automated fashion in terms of having the shapes like that.
The factory makes biscuits in 25 different shapes, from petticoat tails to classic fingers. A rotary cutter produces between 60 to 100 biscuits on every turn, depending on the shape. Today they're making rounds, perfect for dunking. And once they're cut, it's time to get them in the oven.
It's really like your oven back home, but instead of leaving it stationary, we have a moving process. The biscuits are then leaving, you see formed here, they go onto the steel travelling band which goes through the oven, and then that's part of the baking process there.
This baking tray cum treadmill moves thousands of biscuits an hour through the oven.
Rule of thumb, we'd say between 12 and 15,000 biscuits per batch. Over the course of a day, we'd expect one of our production lines to be making in the area of 300,000 biscuits per day.
It takes the shortbread around 30 minutes to get through the 60-metre long oven.
It's a lengthy process, but that's, we believe, has came from our experience. And we believe that to make the best shortbread, or the shortbread we want to put on the market, the baking process is key. And here, all the way along the oven, we can see different viewing hatches where you can actually see the product and how it's forming and how it's baking as the process continues. Looks pretty good there. Well, here we have the end of the baking process. This is the end of the travelling oven. And here we're checking the finished bake of the product. We check the top and the bottom for the golden colour that's expected of our product. The biscuits at this stage are still very hot, probably too hot to handle. So you can turn them over, you can look at both sides, but they are too hot to handle. So we now go into natural cooling conveyors, and they travel along for 30 or 40 metres now before our staff can then handle them. The gradual cooling process, we think, again, is key to our product. In terms of the biscuit industry, we're relatively slow in terms of baking and packing. I mean, some of the lines now are going at very, very high speeds, which we don't aim to do and don't want to do with our product.
Walkers don't rush their shortbread. Slowly baking and cooling the product makes sure they're soft, crumbly, and keep better once packaged.
Well, on the conveyor belt, as you can see, our packing operatives are filling the plastic trays, or skillets as we call them, to be fed into the flow wrapper to head towards the finished product. The biscuit we're looking at today is one of the most traditional forms of biscuit. I believe it was one of the first shapes formed and moulded back in the Jacobite days. We have miniaturised it and made it more user-friendly, let's say, but it is one of the traditional products from back in the day.
Shortbread is often credited to the sweet tooth of Mary, Queen of Scots. Her court included French chefs, who were said to have refined the biscuit bread previously made with leftover dough. They removed the yeast, added butter, and voila, a Scottish icon was born. Back at the bakery, the shortbreads are nearly ready for dispatch.
Well, here we are at the final part of the process, when our product has been wrapped in cellophane, passed through metal detection, and passed into our famous tartan cartons that we use for sending out round the world if at all possible. This last stage we have here is a quality control check, and here you can see Jackie, who's the packaging supervisor, is looking after this part for us. How's things, Jackie?
Oh, I'm fine, thanks, Nicky. How's you?
Good, thank you.
I've just got one coming just now. Ideally, like so this, what we call a lug, is sticking out of the carton. With this pocket, we have two defects, is the date. If the date's smudged or not there, that's a reject as well. Sometimes we have tears on the corner of the pockets, or they ping open, they've not sealed properly, so that's all things that we're looking for. And if it's one of that, we open it up like this, check that the cello is still okay, and we'll repackage it, and that goes into cardboard recycling. Most of the staff are pretty switched on, and they'll preempt things so it doesn't, you know, go out of control. I love it. I just love the people and obviously the products. They're nice and yummy, but they do get to be like a family if you've worked with them a long time. I tend to mother a lot of them, you know.
And how bad the boss is, Nicky?
Am I allowed to say on telly?
I missed the question. What was the question? How good a boss am I? Wonderful, I'll do that. Wonderful. No answer's a good answer. So you have a happy workforce.
Yes, yeah. We all gel. We're like a one big family. I'm part of the Walkers now.
From their humble beginnings, Walker's shortbread is now enjoyed all around the world.
I think we're in over 120 countries, so it never fails to give you a little buzz. You know, even I was out in Mexico there with my wife on holiday, and we walked into the supermarket and there they were, and you can't help take your phone out and take some photographs. I hope that the future is long, and I hope it's steady and profitable, and I hope that the company remains not only a family-owned business, but a family-run business.